We'll start exactly at 3 o'clock.
Sivaji, I am audible?
Yes, sir. You are audible.
Okay, thank you.
Good afternoon, all. Welcome you all for today's second session. The speaker of this session is Dr. Shailesh Kumar Srivastava. Currently, he is working as an assistant professor, Department of Applied Mathematics and Humanities, Sardar Vallabhbhai National Institute of Technology, Surat. He has completed his PhD from Indian Institute of Technology, Roorkee in the year 2015 under the guidance of Dr. Viday Singh. He has qualified CSIR GRF in June 2018. He has received Junior Research Fellowship from January 2009 to December 2010. Also, he has received Senior Research Fellowship from January 2011 to December 2013. He has received Travel Award from CSIR HRDG, Government of India, and UCOST, Government of India, to visit Ankara, Turkey in the year 2012. Also, he has received travel award from DST, Government of India, to visit Las Vegas, USA in the year 2013. He has received travel award from NBHM, Government of India, and IITR Heritage Fund to visit St. Louis, USA in the year 2014. He is having 5 international publications. He has attended seven international conferences. He has organized 1 conference and 2 workshops. He has represented as a session chair in 15 international conferences. With this, he has given 5 invited talks in various institutes. Just a minute. So this is what is a brief introduction. Actually, his curricular vita is near about 15 to 70 pages. Just I have given highlighted points of his curricular vita. So we have such a knowledgeable person with us as a resource person for this session. Now I'm requesting Dr. Shailesh to start his session. Thank you.
Thank you very much, Dr. Sivaji Pawar, for this interaction. And thank you very much also for providing me the opportunity on this platform. I'm also thankful to the Honorable Dr. Kailash sir, Principal SKN Singat, College of Engineering, and Head of Department of General Science and Engineering, Professor Nikam, for organizing such a wonderful faculty development program on this topic. I'm also thankful to the coordinators, Professor Yelappa sir and Dr. Raj Sri, and the members of the organizing committee for putting their day and night effort for making this event successful. And I'm also thankful to the participants here for joining this meeting. So now let me come to my main point. So today we will be discussing about a powerful software, Mathematica. It is developed by Wolfram Research. The latest version of Mathematica is Mathematica 12.1.1, and which was released in the month of June 2020, just before 4 or 5 months ago. And its first version was available in the month of June 1988. The first release date was 23rd June 1988. So I will keep this session as a hands-on experience with Mathematica. So you are requested to discuss immediately if you are having any query in your mind. So let me start. So before starting the session with Mathematica, we first should know how to get Mathematica. How to get Mathematica? Actually, Mathematica is not a free software. It is a paid software, and its price is approximately 1 lakh rupees single user for 1 year subscription. And some institutions also purchase it with multiple key, and they install in the lab either on 30 computers or 60 computers, and those who are having the access with these institutions, they can go to the lab and they can use it. But if you did not purchase the Mathematica, software. So we will see here how to download and install the software first, the trial version. And after that, we will also see how to use Mathematica online, because Wolfram Research also provides a online platform to do all the calculations with Mathematica. It is also not free. Its basic plan is free, basic version is free, but the complete version, the Mathematica software with all full packages, it is not free, neither in offline mode, neither in online mode. So quickly let me explain how to download the software trial version. So let me share my screen. Is it okay? Screen is visible. Dr. Pawar, screen is visible.
Yes, sir. Yes, sir. Your screen is visible.
Okay. Let me do it again.
Yes, yes.
Just present now. Entire screen. So, is it okay now? So I requested to participants to pin me and make the full screen mode. So for the better visibility and better clarity. So, Mr. Dr. Pawar, is it okay?
No, sir. No, sir. Still your screen is not visible.
It is showing you are presenting to everyone. Okay. Let me do it again. Stop sharing. Present your entire screen. Share. Now is it okay?
Yes, sir. Yes.
Is it okay? So to download the trial version of Mathematica, just go to Google and write in the Google Mathematica trial version. Just click on this. So you will find the second link, download a free trial of Mathematica. Now click on this. You will be redirected to this page. Wolfram, the website is wolfram.com/mathematica/trial/. So from here, you can download the trial version. It is written here, try Mathematica for free. Sign in or create Wolfram ID. Wolfram ID means Mathematica is created by Wolfram Research. That's why Wolfram name is coming. Wolfram ID to get your 15 days trial of Mathematica. And this trial includes a download of Mathematica along with the access to Mathematica online. So this account will do both the things. We can download the trial version offline for the desktop or laptop, or using that account, we can also use the Mathematica online. So to do this, we have to create first a Wolfram ID. So to do this, click on create a Wolfram ID. So here you have to put your email address and your first name, last name, and you have to create a password also. Your email ID will be the username, and you have to create a password, confirm password, and create Wolfram ID. Click on this one. Click on this one to create the Wolfram ID. So just create it, and after clicking on this, you will receive an email from the Wolfram Research. You will receive an email. Actually, I have created already. So just I'm showing all the process. Just go to your inbox. Go to your inbox and here you will receive an email from Wolfram account. Click on this. So you have to activate your Wolfram ID. You have to click on this link, given link. It is written here to access all the features of your Wolfram ID account. Please verify your account. So you have to verify your account by clicking on this. And after this, you will receive another email like this, order@wolfram.com. So in this email, you will receive two links. The first one is to access the Mathematica online. I think it is visible to all of you. I am zooming the screen. Okay, it is written, the trial includes both Mathematica online and Mathematica for the desktop, allowing you to experience the power of the desktop environment along with the convenience of the cloud. Cloud means Mathematica online. So for access of Mathematica online, just click on this link and download the Mathematica from the Wolfram user portal. Just click on this link. So I'm clicking on this one. So after clicking the link, you will be redirected to this page. Sign in Wolfram. You will be redirected to this page. So after here, just log in with your credentials, which you have created while making the Wolfram ID. Your username is your email ID is the username, and you have created a password. So just enter. After entering this, you will be provided a window like this. In this tab, My Products and Service, your product is written here. It is Mathematica Trial. Version is 12.1.1. Actually, the latest version of Mathematica is 12.1.1, which in short we say that we say Mathematica 12. The latest version is Mathematica 12, and it was released in the month of June 2020, just 4 or 5 months ago. So this is the license number. You will need this license number while installation. While installation, you will have to provide this license number to activate your account. And go to Downloads tab and click on Get Downloads. When you click on Get Downloads, then you will be provided a window like this. The product is Mathematica Trial. Let me zoom my screen. The product is Mathematica Trial. Version is 12.1.1. This is your activation key. The status awaiting activation. You will need this license key while installation. And you have received, here there are 3 links. Download for Windows, download for Mac, download for Linux. So for all the systems, Mathematica is available. So suppose we want to download for Windows, then click on this. Just on clicking this, you will receive, a pop-up window will come like this. And it is the link for Mathematica Download Manager. Actually, Mathematica provides a download manager, just like LaTeX provides a net installer. These are the download managers. These are not the software actually. These are the download manager to support the downloading process, because Mathematica 12, the size of Mathematica 12 is around 4 GB. So downloading 4 GB software may be difficult if your internet is not fast. So first download this download manager, click on this. Then you will receive an exe file. Just click on this, so in folder, click on this, and it is here, application. So just right click and run as a administrator. This is the Wolfram download manager. It will help in downloading your file. So program name is download manager for Wolfram Mathematica, Wolfram research download. So yes, you can see icon here. The in the downside, downward here, you can see the icon download manager for Wolfram Mathematica 12.1. So downloading has started. So in this way you can download the software, and after downloading it, just go in the folder and just click on the setup. Right click on the setup and run it as a administrator, the second option. So after that you will be instructed step by step how to install it, and in the last you have to provide that license key which you have received in your mail. So let me cancel this, because already I have downloaded the software. So it's all about the process for downloading the Mathematica trial version, 15 days trial version. So now let's come to the how to use Mathematica online. So let me sign out from here. So to use Mathematica online, actually there is no difference using offline mode or online mode if you are purchasing it. There is no difference. So to use Mathematica online, just write in the Google Wolfram, Wolfram Cloud. Just write Wolfram Cloud in the Google it, and just click on the Wolfram Cloud, the first link. After clicking this, you will be provided a window like this, Wolfram Cloud. And this is the basic plan written here, basic plan. It is free. So just earlier I told you that basic plan is free, but you cannot do all the calculations with that basic plan. Means you cannot make a particular code for your research problem, because this basic plan is free and it will not be loaded with all the full facilities, all the full packages, all the commands given by Wolfram Research. So click here. If you want to use free, then you can take basic plan. It is free, and you can use this to start with Mathematica, to learn simple basic things. Now click here, sign in, and remember that we have created an account while downloading the Mathematica. So directly actually login to pehle se tha. So it is written here in the upper part. You can see trial version, 11 days left. So I have created 3 to 4 days ago. So that's why 11 days is left for this one trial version. And if you take basic plan, then it has no expiry. So here basic plan, you will find here basic plan written. Basic plan will be written here instead of trial 11 days left. So you can click on quick links. From here you can see getting started, 5 minutes hands-on intro, something to try, 1 minute video, fast intro for maths student, fast intro for programmers, and all these things. So after getting this page, after logging into Wolfram Cloud, just click on New Notebook. Just click on New Notebook. After clicking this, you will be here. This is your online platform for using Mathematica. So it is unnamed. You can name it, and you can start from here. Just like just think Mathematica like a calculator first. Just 2 plus 2, it is 4. Actually, to get the output in the Mathematica, we have to press Shift plus Enter. We have to press Shift and Enter. Just hold down the Shift key and then press Enter in order to get the output. So actually, this is the Mathematica notebook. This is the Mathematica notebook, and it is the interface between the user and the Mathematica kernel. Actually, Mathematica kernel takes the input given by user from this Mathematica notebook and evaluate it in the background silently and produces the answer in the form of number, in the form of graph, or in the form of other suitable things. Working in the background. We will communicate with the help of this Mathematica notebook. So we can do all these things because I have 11 days left with this trial version. We are doing this online. It is Mathematica online. It is not Mathematica offline. Offline, after downloading it, you have to install it. And the installation is also easy process. So we can do all these things. Suppose we want to plot. So when you write plot, then you will get different options: plot, plot 3D, plot range, plot style, plot label, plot marker, plot point, plot range, padding. These are the different commands starting from plot. So let me increase the font size. So everything in Mathematica, just remember, these are the basic things. Actually, these are the basic, but these are important. Without learning these things, we cannot go further. We cannot go ahead. So each command in Mathematica starts from the capital letter. Just remember, each command, each inbuilt function, each built-in command, each built-in symbols starts from the capital letter. So in plot, P should be capital. This is the syntax. Syntax may be different for different softwares also. While using MATLAB, MATLAB is not case sensitive. So P may be small in MATLAB also, but in Mathematica is case sensitive. So small plot plot doesn't, Mathematica will not recognize this. So plot, and anything which starts, any inbuilt function, any inbuilt command starts from the capital, and all the arguments we have to give in square bracket. There are 3 kinds of bracket: square bracket, curly bracket or curly braces, and round bracket, round or parenthesis. So we have to give the arguments. We have to give the arguments of any function, any inbuilt command in square bracket only. Suppose we want to plot the graph of sine x, and so we have to write like this: plot sine x and comma. We have to also give a range for the variable x from a 0, 2 pi. So while writing pi, we should take care that P should be capital. P should be capital. Pi is 3.14 like this. So P should be capital. Just to get the output, what to do? Just press shift plus enter. Shift plus enter. So this is the graph of sin x. And suppose we want to plot two graphs, three graphs, or more than one graph on the same axis, then we can do like this. Cos x, shift enter. Actually, let me explain again. Mathematica is case sensitive first thing. Each command, each function, inbuilt function, sine, cosine, tan, cot, or any inbuilt function, pi, exponential e, so small e will not work. Capital E we have to write. So all these starts from the capital letter. Each command will start from capital letter. Suppose P in plot, P should start from capital letter. And curly braces like this. Curly braces or curly bracket. Let me zoom it. So let me go to offline mode. We can do each and everything in online mode also, but let me go to offline mode. It will be comfortable for me. And online mode also depends on the quality of internet. If internet is slow, then it will take much more time. But if you install the Mathematica, then do not worry about internet speed. So right here, Mathematica. This is the default view of the Mathematica. This is the default view. This is the Mathematica notebook. This is the Mathematica notebook. This is the default view. And here, there is option file, edit, insert, format. In format, suppose we want to give some heading, give some title. So go to format, go to style, and go to title. Click on title. Then anything you will write this here. And it will not be executed by the Mathematica kernel because you are writing in the cell with label title. You are writing title of anything. So it will be in the cell. Click here, right hand side. You can see on the upper right side, on the upper right corner, you can see there is a cell. There is a cell. So this cell, in this cell, you can write anything. Just press enter to go the next cell. Just press enter to go to the next cell. And you can make color also, different color, text color. So suppose I am taking red. So now it will be red. So each and everything in this cell will be treated as a heading, as a title. And similarly, we can also write subtitle. The font will be smaller. The subtitle, the font will be smaller than subtitle, section, subsection, text, code, input. When we give input, then Mathematica kernel will execute it. Otherwise, not. So to write the input, to give some input, to write a command, to write a code, just get out from this cell. You can see here, this is the cell. Right upper corner, see the right upper corner. This is the cell. So just come out from this cell, and let me increase the font size. You can increase the font size of this notebook from the right lower corner. It is here. It is at the present it is 100%. We can make it 200% or 300%, like 200%. So to give some input, we have to come out from this cell and when the cursor becomes horizontal. These are the basic things actually we should know. When the cursor becomes horizontal, then click. Then after clicking, your new cell starts and automatically it will be an input. You can check it. Style, input. So from here we can write anything. like 3 plus 8, 11. So let me delete all these. So to get a new cell, we have to click when the cursor becomes horizontal like this. Here cursor is vertical, here horizontal. So here we can click. Here also horizontal. Here we can click, and we can start plot sin x. So remember, each command will start from the capital. Each inbuilt function will start from capital. We have to put S capital in sin x. We have to give argument in the square bracket and comma. We have to give the range also. Suppose I want to plot the function from 0 to 2 pi. In pi, p should be capital. So just press shift and enter. This is the graph. Suppose we want to plot another function on the same axis. Then what to do? Then we have to put here cos x also, the next function. And in between there should be a comma, cos x, sin x. But there are two functions. So just I earlier told that capital square bracket will be used to give the input, give the argument. Argument will always be given in the square bracket, capital bracket, square bracket. And curly braces or curly bracket will be used to give the list like this. X varying from 0 to 2 pi. I have included in the curly bracket or curly braces. So here also we have to include cos x and sin x. Suppose I want to evaluate it, then press shift and enter. Then we are getting an error. Error is saying that in plot cos x, sin x, this an option must be rule or list of rules. So you can click this arrow, double arrow, to get some more information about this. But we know where we did mistake. We have to make a list. We have to make a list of functions with the help of curly bracket, curly braces. So just press shift and enter. Cos x and sin x, x0 to 2 pi. Oh, it is capital actually. This is the way to find the mistake actually. When we start writing anything in the Mathematica, like I'm writing plot P, it starts with the blue color, PLO, it starts from the blue color. And when it matches with any inbuilt command, inbuilt function or user defined function, it turns black. So black means you are right. Suppose I am writing PLAT plot. So it is not black. So Mathematica did not recognize this PLAT, because if it recognizes it, if PLAT is any inbuilt command or inbuilt function or user defined function, then its color will be black. So I know what mistake I did. Here I am writing small x for the variable, and here I am writing capital X for the variable. So I have to put small x here. So press shift and enter. You are getting these two. So these are some basic things. So let me start from the beginning. So it is a request to the participants that if you are having any doubt, then you can immediately ask, immediately discuss with me. Please turn off your mic, and after discussing, again turn off your mic. So Sivaji, is it okay? Going everything okay?
Yes, sir. Yes, sir.
Okay, thank you. So I have told that suppose we want to write pi, so p should be capital. So we can you can write all these symbols from this command here. You will find here pallets, P-A-L-E-T-T-S, pallets. Just help is written in the last. Just before this, the window is written, and before this, pallets is written. So click on pallets, and then basic math assistant or classroom assistants. So click on basic math assistant. Then you will find this small window. Let me increase its font size. Let me give it 200. So this is the palettes. Here you can, with the help of this, you can just with single mouse click, you can create theta, pi, e, iota, infinity, and all these. And here all the important commands are also written here, like this basic command simplify. Simplify will simplify your expression. Solve, expand, and solve, factor, find roots. We will discuss all these. And in advanced tab, you will find sine function, cos function. Directly you can click here and it will appear. It will appear on your Mathematica notebook. So either you can write manually each and everything, or you can use this palettes. With the help of a single click, you can access all these things. You can input matrix also from here. Just click on this and start writing the matrix. And you can input the matrix from here also. Insert, go to insert, go to the table matrix, new table, new matrix. Here matrix, list of number of rows 3, number of columns 3, and then click OK, and then put the elements, different elements. So these are the simpler way, but we can input the matrix manually also. So we will see in the upcoming discussion how to input the matrix manually, how to find out its inverse, how to find out its transpose, how to check whether the matrix is symmetric or not. All these things I will discuss. So this is the palettes. It may be useful for taking the symbols directly, just with the help of one click. So let me close this. So, one more thing. While using the Mathematica command, generally we have to type this arrow for option. So just type the minus sign and just greater than sign and space. Then it will convert it into this arrow. And similarly, the greater than or equal to, you can write like this. It will be greater than or equal to. Less than or equal to, write this. Less than or equal to. Less than or equal to, you will write this. And not equal to, you will write with the help of this series of symbols, this one and equal to. It is not equal to. Although you can take all these symbols from the palettes also, but you can write manually also. So this is the basic things. And again, let me go ahead. I have explained about the kernel. Mathematica. This is the Mathematica notebook, and kernel works behind it in the background. We will communicate with the kernel with the help of this Mathematica notebook. Kernel take the input, our input, and execute it, and responds in the form of answer over this notebook. So this is the thing. And suppose we want to write square root of 5, then we have to write SQRT. SQRT. Each and everything will start from capital. Again and again I am saying. And input will be given into the square bracket. SQRT 5, square root 5. So shift enter. Just make a new cell here. Let me write again SQRT 5. shift enter, square root 5. So square root 5 you can write like this way, or also you can use palettes, basic math assistant. Just I'm giving an example to show how to use these palettes. Just by a single click, you can click on this one. This is the square root 5. Mathematica gives the exact value actually. If you want the numerical value, then you have to write this numerical value. Double slash capital N. N stands for numerical value. N stands for numerical value. So numerical, and Mathematica gives the numerical approximation up to 6 significant digits. It is by default, and if you want to more, then you have to write like this, capital N. Suppose I need the value of pi up to 10 places, decimal places, like write like this. Up to, suppose up to, I need the value of pi up to 100, write like this. Suppose I up to 1000 decimal places, write like this. Similarly, I want to value of E, numerical value. You give up to 6 significant numbers, and if you want more, then you have to write here up to what number you want to extract the value of E. Suppose 10, then shift enter. Suppose 100, then again. So these are the things, and let me start from here. Suppose one more basic thing. Suppose we want to 2 into 3 plus 6. Suppose we want to do this. So Mathematica multiply first. First Mathematica multiply, then divide, then add, then subtract. So if you want to if you want to execute the part of an expression, then just simply select that and press Control and Shift and Enter, and then again. Just I want to say that suppose 6 plus 8 multiplied by 6 multiplied by 5 plus 5. Sorry, plus 3. Suppose I want to multiply 8 and 6 first, and then I want to execute with the rest. Then just click 8 and 6, 8 into 6, the part of the expression which you want to execute first. Then instead of Shift plus Enter, click Control, press Control key and Control, then Shift plus Enter. Then it is 48. And then again Shift plus Enter in order to calculate all the values. So Shift plus Enter should be pressed in order to get the output. And if you want to execute any part of the expression, then select that part only and press Control plus Shift plus Enter. So this is the next thing. And suppose to suppress the output in Mathematica, we use just semicolon. This semicolon will be used to suppress the output in the Mathematica. Just let me define A equal to 1. Press Enter. Press Enter to go into the next line. Shift Enter will give you the result, your output, and simply pressing Enter, you will be get in the next line. You will go in the next line by clicking Enter. So suppose I'm assigning A equal to 1. A is the variable. A is any variable. I'm assigning A equal to 1 and B equal to 2 and C equal to 3. B equal to 2 and C equal to 3. C equal to 3. And then I want to add A plus B plus C. Then Shift Enter. Then here we are getting all the results. The value of A is 1, value of B is 2, value of C is 3, and then in the last A plus B plus C. So to suppress the output, just put the semicolon. Suppose I am putting the semicolon, and then press shift plus enter. I am getting the result for this also. So this is helpful. This command will be helpful when only last result is required. Suppose you are doing a lengthy calculation and you do not need the smaller output of the smaller results, intermediate results. Then you can put a semicolon. You have to put a semicolon to suppress the output of that and just take the required result, final result. So, and also one more thing, how to comment in Mathematica. Just anything written in this square bracket and this star, it will be ignored by the Mathematica kernel. It will be ignored by the Mathematica kernel. So just suppose I want to add 12 plus this one. Suppose here I am writing anything you can write. It will be ignored by the Mathematica. The square bracket and the star. Anything written under this will be ignored by the Mathematica. Then plus 4. So what should be the answer? 16. 16 is the answer. Mathematica kernel does not read this. It will ignore this and only evaluate 12 plus 4. So in this manner we can comment, we can write something. So go to the next cell. So I told that Mathematica is the case sensitive. So to integrate a function, we have to write. We should start from capital I. Integrate a case sensitive hai. And square brackets are used for function arguments. So again, I am repeating sign. We should not write like this. Sin x. ऐसे नहीं लिखना है. We have to write like this, sin x. And round brackets will be used to make the list always, and curly brackets are used. Round brackets will be used for grouping. Round brackets will be used for grouping. Suppose 6 into 6 plus 7 minus 5. Suppose we want that 7 minus 5 should be added into 6. So we have to put all these into a square bracket. Then execute. So for grouping purpose, suppose I am giving an example. Suppose I am writing x square plus 2. So see what is the output. This is x square plus 2. But if you want to write x square plus x like this, x square plus x, x square plus x, square plus x, then you have to write like this. This is x square plus x. So square bracket should be used for grouping purpose, and curly brackets or curly braces for the list. So and one more thing, let me explain. Suppose I want to evaluate the value of square root 81. I know that the result is 9. So press shift and enter, it is 9. But if you write from the small letter sqrt 9, then your output is same as the input. Because in this case, just understand this thing. In this case, Mathematica did not recognize this small sqrt. Mathematica did not recognize this small sqrt because it is neither a user-defined function nor an inbuilt function. So it is giving the output as it is. So if you are obtaining the output as it is, It means that Mathematica did not recognize it. But if you the color is blue, and if you write capital S, then it will match with the inbuilt function, inbuilt command sqrt. So color turns black. So press shift and enter, it is 3. And this percentage, this symbol is used to extract the previous result. This previous to previous. This is the previous and this is the previous to previous. So similarly, we can use this percentage sign to retain the previous results. So Mathematica gives exact answer. Mathematica gives exact answer. Suppose, let me make a new cell, sqrt 12. Mathematica gives exact answer. It is 2√3. If you want approximate answer, then you have to write like this, capital N. And if you want to more decimal places, then write capital N sqrt 12. And suppose I want 50 decimal places, or 50 significant places. I want the answer like this. Otherwise, if you not use this capital N, then Mathematica will give you exact answer always. The exact value of pi is pi. But if you want to know the value of pi up to 10 decimal places, then you have to write like this. So this is one more thing. So one more thing. Suppose we want to multiply two symbols like A and B. Like this, 4 space 5. Space meaning product. If you are giving a space between two numbers, it means you are multiplying that two number. 4 into 5, like this. 6 space 7. 6 into 7, like this. And similarly, if you are writing two symbols like A and B, then remember that this is not the product of A and B. It is another symbol. Mathematica will recognize it as a new symbol starting from A and ending with B. And if you want to write A into B, then you have to write like this. A space B. We have defined A equal to 1 and B 2 earlier. So Mathematica is taking A equal to 1 and B equal to 2. We have defined the variable by its values. So whenever at any place, whenever A and B will come, A and B will be replaced by its value, A equal to 1, B equal to 2. And to remove that, we have to clear that also. Clear A. Shift enter. Now, one more thing. In this way, you can clear a variable definition. Suppose now A is not 2. Suppose A is A. But B equal to 2. We have not cleared B. We have cleared only A. So B equal to 2. B equal to 2. Just press shift enter, B equal to 2. And if you forget, after defining a variable, if you forget what value I have defined, then there is one way to recall this. Just press this and press B. Suppose you want to know what value you have defined for B. So just press shift enter. B is a variable, it is a global variable, and you have given to the value B. You have defined B equal to 2. And let me clear B. Clear B. Just press shift enter. Now check for B. Now the definition of B, the value of B has been removed. But still, Mathematica recognize B as a symbol. Here you can give another value to B, but B also B is in the list of Mathematica symbol. It recognizes B as a symbol, but it forgets B equal to 2. You can define B equal to some other value. And to remove completely, you have to use this command. Remove, not clear. It should be remove. Remove B. Now press shift and enter. Now check. Information not found. You are looking for B. You are looking for B. Now we have removed the B. So information not found. Symbol B not found. Now B is removed from the Mathematica symbols list also. So these are the two. And in the single command, in the command clear, you can clear more than one variables also. A comma B. एक साफ कर सकते हैं. Or format or remove A comma B comma C. More than one symbols can be removed or can be cleared with this command. Just separated by comma. Separate all the commands by comma. No need to remove or clear one by one. So this is one more thing. So to multiply A and B, just either write like this or just make a space, either one space or more than one space. More than space will also work. Just like this. Shift enter. This is AB. Not like this. This is not the product of A and B. This is not the product of A and B. This is a new symbol starting from A and ending from B. For product of A and B, you have to make a space or you have to put a star between these two like this. Like 4 space 7. It is a product. Space means product in the Mathematica. But if your expression starts from a number, then it is not like that. 2x. 2x is product of 2 and x. You do not need there is no need to put the space between 2 and x. When you are multiplying two symbols, then you have to put a space or you have to put a star or cross sign from the pellets. But if you are writing 2 into x, then directly you can write 2x, 3f, directly write, you can write. This is the product 3 into f, because it starts from a number. So we should keep these points in mind. So I have also explained how to find the numerical approximate value of any inbuilt symbols or any expression. Then come to the help. Actually, anything you want to help and click on Documentation Center. Click on Documentation Center. Go to help and click on Documentation Center and search here whatever you have in your mind. Actually, while working with Mathematica, there is no need to ask to someone how to do this thing, how to do that thing. Just go to in the help, click on Documentation Center and search whatever you are having in your mind, whatever you want to do this with, we want to do with Mathematica. Just click, suppose I want to integrate. Then click here, integrate. Search for integrate. Then you are getting the syntax. For integrate a function, just write integrate with capital I. Sivaji, everything is okay?
Yes, sir. It is okay.
Okay. Yeah. So just go to search, write the thing what you want to do and press enter. Then you will get a syntax of integrate. Integrate, I have already told that all the inbuilt functions should start from capital letter. So integrate, in integrate I should be capital, and in the square bracket, because all the arguments should be given in the square bracket. Mathematica reads like this, in this way. Actually, we have to know how Mathematica is reading anything. First of all, we should know this, how to give the input, how to make a list, how to grouping, how to make a group. So integrate, and in the square bracket, this is the function, and this is the variable with whom you want to integrate. And for a definite integral, just write x minimum to x maximum in the curly braces, because it is a list. And if you want to integrate more function, then write like this. So here you may find examples also, like integrate this one. So let me copy this. See, copy and paste. Shift enter. This is the answer. You can simplify this also with the command simplify. So integrate, in integrate I should be capital, and the function should be written in square bracket, and you have to write also the variable with respect to with which variable you have to integrate. Suppose there may be more than one variable in the, and suppose you want to do the definite integral, so you have to write like this. X is the variable, and suppose I want to put the lower limit 1 and upper limit 2. Just press shift and enter. Mathematica is running. This is the answer. This is the answer. Mathematica put x equal to 2 and then put x equal to 1 and subtract it. After putting the upper limit and lower limit, it is giving the simplified result. So we have to use the curly braces here also. Whenever there are more than one thing, just remember, whenever there are more than one things, then we have to enclose that into the curly bracket. So, suppose one more thing. Suppose you know that the command plot graphs a function. You know that the plot command plot a function, but you but you do not remember its syntax. You do not remember how to write the syntax for plot. But you know plot do something. So for this, just write this mark, this symbol, and write PLOT plot. Just press enter. You will be provided with the exact syntax. Mathematica will provide you the exact syntax. See here, in the plot command, P is capital. The argument is in the square bracket. This is the function, and this is the range of the variable x from minimum to x from maximum. Generates a plot of x as a function of x from x minimum to x maximum. Very easy to find. Suppose we want to plot more than one function, then again in the curly braces, f1, f2, so on, x minimum to x maximum, so on, plot several functions fi. And if you want to explore more about this, then just click on this symbol. You will find some examples also. See here. You are getting the syntax here. It is written here. And some examples are also given. You can take help with these examples. This is the example of three plots, sin x, sin 2x, sin 3x. Three functions are plotted on the same axis. And if you want to know more, if you want to know all the attributes, all the options related with plot, then write like this. Double, then plot. Then press shift enter. Then you will find all the options available with the command plot. These are all the options available with the command plot, like plot style, frame, axis level, legends, and all other things. Axis the plot also. If you want to caption the plot, if you want to write any name either in the upward side or lower side, then all the things you will obtain here. And suppose one more thing. Suppose you know that you remember just only part of a command. Suppose you are just remember only part of a command. You forget the full name of the command. So for that, just write the name. Suppose I'm writing, I'm looking for inverse functions: sine inverse x, cosine inverse x, tan inverse x, cosec inverse x, like this, and that are inbuilt like arc sine, arc cosine, arc tangent, like this. So suppose you remember only the part of a symbol name, then just write the part and just press the Control and K. See here. Again, I am explaining. Just you want to know the part of any command, not the full name of the command, then just write that part only and just click Control K. Then you will be provided all the commands starting from the arc. Suppose we are looking for arc cosine, sine, and then you can click on the one you want, like this. Suppose you know the plot command, but you know the complete syntax for this. Actually, this is going to be very helpful. Suppose we do not know the complete name of the command. So just we know the plot starts from PL. Suppose PL. So just Control and then K. These are the list of commands starting with PL. Placed, play range, plot. Plot is also here. Plot 3D, plot 3 matrix. All these also here. So like this. Suppose I am writing PLO. Control K. You will get plot 3D. All the commands starting from PLO. ये सारे आ रहे हैं मेरे पास. किसी को देखना है प्लॉट को देखना है तो प्लॉट को क्लिक करो. Click on the plot. You will get plot here. So this is the important, and this is not the only way to do this. There is one more way to find out these things. Suppose I want to explore the inverse command. Inverse of a matrix, inverse of other things, inverse Fourier transform, inverse Laplace transform. But I do not remember right now the exact full name of the command, and also do not remember the syntax, how to find the inverse Laplace transform, how to find the inverse Fourier transform, inverse sine Fourier, inverse cosine Fourier, inverse of a matrix also I do not know. So for that, what to do? Just put this symbol and just like INV. Suppose I am looking for inverse. So INV, inverse. But we should know that all the commands start from the capital letter, because small INV if you write, then any inbuilt command does not start from small I. तो वो तो किसी को सर्च नहीं कर पाएगा. तो capital INV and then this one. Then put this. It will shift enter. It will give you all the commands which starts from INV. It will give you all the commands which starts from INV. So suppose inverse, I want to know about this inverse. Then click on this. Inverse, in square bracket, inverse, I should start from capital. In the square bracket, M. M is the matrix actually. Gives the inverse of a square matrix M. So till now we have not seen how to input a matrix in the Mathematica. You can input by inserting it. You can input with the help of palettes. But by manually, we till now we did not see how to input. I will cover that also. So, and also if you want to explore more about this inverse command, then just click over here. Just on these symbols. So you will find some examples, and you will find some click on this inverse Laplace transform. So thus inverse Laplace transform, right? The syntax is this: inverse I capital Laplace L. See here, all the commands starts from capital letter in the Mathematica, but there are some commands also which involve more than one capital letter, like this inverse Laplace transform. So inverse Laplace transform, there are 3 capital letters, I, L, T. तो अगर इसमें किसी से भी गलती हो गया, स्मॉल टी हो गया, तो it will not run. और स्मॉल टी हो गया तो it will not, the color will not be black, it will be blue. Color will be black only when it matches with any built-in function, built-in command, or user-defined function or user-defined command. So this is the syntax: inverse Laplace transform, in square bracket put your expression and comma s comma t. S comma t gives the inverse Laplace transform of expression, and inverse Laplace expression S1, S2, T1, T2 gives the multi-dimensional inverse Laplace transform of expression. And if you want to explore more, then just click on this. So by clicking this, you will find some examples also. So this is one way to do all these things. And also, suppose just I want to explore plot command. So PLO star. Just press shift and enter. This is the list of all plot commands, all the commands which starts from PLO. So same thing I am doing in different way. Just you can write this symbol and write plot and press shift plus enter. Then you will find all these information. Just write PLO and just control plus K. Then you will find all the list of the commands starting from PLO, containing PLO. But here you are having one more benefit. This is all the list of the commands starts from plot, and also you can explore one by one. Suppose clicking on plot. So this is give plot function x minimum x maximum generates a plot of f as a function of x from x minimum to x maximum. Plot f1 f2 plot several functions. Plot 3D plot, then plot 3D. This is the syntax: plot 3D function and x minimum x maximum, y minimum y maximum. It is the command for a function involving 2 variables. Z equal to function of x y, like this. It generates a 3-dimensional plot of f as a function of x and y. And if you want some example on this, then just click over here. So this is another way of exploring all these things. Now, suppose I want to find all the commands which includes our hour in the middle. Then what to do? This one, this our hour, and this one. Just press shift and enter. This is the list of all commands. This list of all commands which include our in the middle of their name. Like our is coming here. Yes, our. Fourier, FOUR, Fourier. So click on Fourier. Then your Fourier list finds the discrete Fourier transform of a list of complex numbers. Fourier inverse Fourier sine transform. Just you can click on anyone and you can find the syntax for that. And if you want some examples also, then just click on this symbol. Then you will be redirected to a page where you will find some examples with this also. Syntax plus examples. So by this way, we can explore all these. Now I want to know the simplify command. Just write this one, shift enter. The simplify expression performs a sequence of algebraic and other transformation on expressions and return the simple form it finds. Simplify expression plus assumptions, that simplify using assumptions. Suppose you are taking any assumption, then keeping that assumptions in mind, the Mathematica will simplify that expression. And if you want some example, then click here. So these are the some basic things which we should know. Now come to the, now let me do some calculations now. Let me do some calculations. So these are the basic things. Much more we can do with this software, and these basic things will help you to start with Mathematica. Without knowing all these things, you cannot start. If you do not know how to give a value of the variable, how to clear or how to remove the variables, how to find the numerical value, how to write, what are the syntax, how Mathematica is reading all these things. So let me do some calculation. So how to solve some algebraic equations? Let me solve some algebraic equations. So let me take one new notebook. One more thing. With the same time, you can work with multiple notebook. You can work with multiple notebook. This is your another notebook. Just close this. You are here. Just close this. You are here. This one and this one. You can work with multiple notebook. Suppose I want to assign a equal to 4. A equal to 4. So suppose I want to calculate now a square. Then it will be 16. Wherever Mathematica finds a, it will assign a equal to 4. But if you are working with parallel notebook, multiple notebook, then just remember that in the second notebook also, a is 4. Mathematica will take a equal to 4. Just check it. A cube. Just check it. It is 64. Mathematica is taking 64. And suppose if you are changing the value of a in the first notebook, suppose remove a and assign some new value to a equal to 5. Then in the second notebook also, Mathematica will consider a equal to 5. Just check. A raised a square is 25. So simultaneously, if you are changing the value of one variable in one notebook, then it will change in the other notebook also. The same symbols will be affected. But if you are working with only one kernel, single kernel, because kernel is same, your notebook is different, but kernel is same. So by changing in one, it will affect the symbol in all notebooks. Its value will change. Let me close this. Don't save. Now let me use a fresh notebook, because I have used a different different symbols, so it will create a problem. So Mathematica इक्वेशन सॉल्व करेंगे तो पता नहीं चलेगा x की वैल्यू हो सकता है 4 5 दे रखी हो, भूल गया वो तो क्या दिया था, बेटर है इसको सॉल्व करते हैं. फ्रेश नोटबुक आई एम टेकिंग. सो लेट मी इंक्रीज इट्स साइज 200. So how to solve a algebraic equations? So for solving algebraic equations, SOLVE, solve. This is the command. It is blue, it turns black. It matches with the inbuilt command solve in the Mathematica. It is blue, now it is black. It starts from the capital letter. So argument should be given in the square bracket. So suppose I want to solve x square equal to simple algebraic equation. X square plus 1, just I'm writing x square plus 1 equal to 0. To write equal in Mathematica, just write 2 equal. It is a syntax. In Mathematica, while solving equations, you have to write 2 equal to 0. And I want to solve for it for x. So this is the answer. Again, it is not x equal to I. It is x approaching to I, and it is x approaching to minus I. Actually, this is the answer. X equal to I and x equal to minus I are the solution, are the roots of this one. Actually, this is the standard way for writing the solution. Mathematica use this. So here we can consider x equal to I and x equal to minus I are the solution. And suppose we want to solve another equation, then write solve just in a square bracket x cube minus 2x plus 1. To write cube, just press control and 6. See again, x, either write like this, but if you do not write like this, then directly there is a shortcut, control plus 6, x cube minus 2x. It is 2 into x, because Mathematica, if you are writing any number, then a symbol, then Mathematica treats it as a product. So 2x means 2 into x, not 2x as a variable. But if you are writing a into b, simply ab, then Mathematica treat it as a new variable starting from a and ending with b. So just x cube minus 2x plus 1 equal to 0 and solving for x. Just shift enter. This is the value. X equal to 1, x equal to 1 by 2, minus 1 minus root 5, x equal to minus 1 by 2, minus 1 plus root 5. Suppose you want to numerical values, then you have to put n solve. Then shift plus enter, and numerical values. One value was x equal to 1 and other was this. Suppose I am writing just simply solve. So x equal to 1 by 2 minus 1 minus root 5, x equal to 1 by 2 minus 1 plus root 5. So if you want to you want to find the approximate value, numerical value, then you have to write n solve. So in this way you can solve, and you can solve simultaneous equations also. Suppose I want to solve 2 simultaneous equations. Solve. So for simultaneous equation, suppose I am writing the first one, x plus 2y equal to 2, and for the second one you have to separate by this and symbol. Write the second, x plus 4y, like x plus 4y equal to 3, and solve for x and y. So you have to enclose it into curly braces, x comma y, then press shift enter. There is some mistake. Solve x plus 2y equal to, and there is single equal, x plus 4y equal to 3. So press shift enter. X equal to 1 and y equal to 1 by 2. X equal to 1 and y equal to 1 by 2. So suppose I want to do something with this first value of this list. First value. So how to take the first value? Suppose I want to extract the first value. Then say, just I'm giving the name. Say e equal to percentage लगाना पड़ेगा ना, percentage, and like this 1. It is giving the whole digit. Okay, actually here I have to give capital A equal to this one. So capital A equal to this. So capital E equal to, suppose I am writing capital A here. So first value. So we will see. Just now come to how to input a matrix. I have to cover plot also, 2D plot, 3D plot. I have to cover. So just quickly see how to input a matrix. Just to input a matrix, you can go to insert. Again, I am telling, go to table, go to new. Either table or matrix, whatever you want to create, you can create. You can put the number of row here and number of columns here and click OK. Then in that way, you can create a matrix. By going in the palettes, basic math assistant, you can also create a matrix like this. Create a matrix like this. And just put all these elements of this matrix. But how to input the matrix manually? Then there is a method. Suppose I want to put the matrix A equal to, just I am saying the matrix A equal, just I am giving the name A, capital A. The matrix name is capital A. Just write in the list. In the first curly braces, 1, 2. This is your first row. This is your second row. 2, 3, suppose. Just press enter. This is your the matrix A, which first row is 1, 2 and second row is 2, 3. This is the standard form. This is the first row and this is the second row. And if you want to see the matrix in the traditional form, then you have to write like this, matrix form. M-A-T-R-I-X, matrix, F-O-R-M, matrix form. First row is 1, 2 and second row is 2, 3. This is your the matrix A. Now you can do many more things with this matrix. You can find out its determinant, inverse, eigenvalues, eigenvectors, all these. But remember that when you are writing the matrix in the traditional form, then you cannot operate anything on this matrix. Suppose I want to find eigenvalues. Eigenvalues, I am not remembering the exactly syntax, how to write the eigenvalues. So just I will write I-E-I-G-E-N. Just press Control and K. These are the 3 commands starting from eigen, E-I-G-E-N. Eigen system, eigenvalues, eigenvector. So one by one we can discuss. Let me click on eigenvalues. Eigenvalues of this A, you get an error. You are not getting the answer actually. So for getting the answer, you have to remove this matrix form. Now you can find eigenvalues of A. These are the eigenvalues of this matrix. If you want to see in matrix form, then write matrix form. Press Shift Enter. These are the eigenvalues. Remove this. Now eigenvectors, E-I-G-E-N, eigen, V-E-C-T-O-R-S, eigenvectors. Eigenvectors of this matrix A. These are the eigenvectors. This is an eigenvector corresponding to first. This is an eigenvector corresponding to second. 2 minus root 5. But if you want to generate eigenvalues and eigenvector both at a time, then use the command eigensystem. There is one more command, eigensystem. Eigensystem will generate eigenvalues and eigenvector both at one time. Eigensystem. So let me do with this. E-I-G-E-N, eigen. Control K kare. Eigensystem. Yes, eigensystem. This matrix A. This is the eigen. The first list denotes the eigenvalue. 2 plus root 5, 2 minus 5 root 5 is the eigenvalues. And the second list denotes the eigenvectors. This is the eigenvector corresponding to first one. And this is the eigenvector corresponding to the second one, So in this way, we can find the eigenvalues and eigenvectors. So you can write the 3 cross 3, 4 cross 4 or 3 matrix with higher row or columns, and you can calculate the eigenvalues and eigenvectors of that matrix. So suppose I want to create one. Okay, leave this topic. Actually, this is easy. I have to cover plot, and I am having less time to cover that. So I am skipping all these basic things. And one more thing for transpose. Suppose I am giving the just giving the name trans to the transpose. Transpose, transpose, transpose. And if you are not remembering this command, then just write trans and press Ctrl K, or just write this. Just write this one. This trans trans. Put this one. Press enter. Transformation function translate transpose. Click on this. Transpose list. Transpose the first two level in the list. Transpose of a matrix. Transformation of a matrix. Translate. Actually, list, in place of list, you have to put matrix if you are working with matrix. So trans equal to transpose transpose. Suppose I want to calculate the transpose of the A matrix, then click on this. This is the matrix transpose of this matrix. First row becomes first column and second row becomes second column. Remember this matrix. First row was 1, 2. So 1, 2 is now the. Actually, this is a symmetric matrix. I have entered a symmetric matrix. So its transpose will be the same. Let me write another matrix. First of all, let me clear A. So now let A equal to, let me write 3 matrix and let me work with that. First element, first row is 1, 0, 0, 1, 0, 0. It is 1, 0, 1, 0, and 0. And the second row is 0, 2, 1, 0, 2, 1, and comma. Separate all the list by comma. 2, 0, 3. Suppose I am taking 2, 0, 3. So this is the matrix. You can see its matrix form. Matrix form. This is the matrix. So just I want to calculate its eigenvalues and eigenfunctions. To calculate eigenvalues, eigenfunction, eigensystem, transpose, determinant, we have to remove this matrix form. With the, when we are looking at matrix form, we cannot do all these operations. So just remove all this. Press shift enter. This is the matrix standard form. Mathematica recognize it like in this way. So just eigenvalues, EIGEN, eigenvalu, eigenvalues of this. This eigenvalues 3, 2, 1. Eigenvectors. Eigen VECTORS eigenvectors. There is some mistake because it did not turn into black color. VEC, na? VEC eigenvectors. Capital A. This is the eigenvector. The first one is the eigenvector corresponding to 3. Second one is the corresponding to 2. Third one is the corresponding to 1. Just if you want to calculate the eigenvector and eigenvalue both at the same time, so eigensystem. We have to write eigensystem for the matrix. This one is the list of eigenvalues. This is the second list, is the list of eigenvectors. And even we can do more than that. Suppose I want to calculate the eigenvectors, eigensystem. Suppose I am writing 2. Then this command will give you the highest, largest 2 eigenvalues and eigenvectors corresponding to that. Suppose I am writing here 1. Then 3 and eigenvector corresponding to 3. So if we write here k, then the eigensystem will produce the k eigenvectors starting from the largest to the kth level, and for each eigenvalue it will give an eigenvector. So we can do transpose, we can find determinant also, DET, determinant of A. 6. Eigenvalues, eigenvector, determinant. We can find inverse also. So you don't know how to write the inverse, then write INV and plus control K. Inverse of this A. This is the inverse of this matrix. If you want to see in matrix form, then matrix form. This is the matrix form. And how to check the inverse is correct? A into A inverse. A into A inverse. Just do this. A into. For this, you have to give some name. Suppose I am writing INV equal to this. INV. So A into INV. INV is the inverse of A. So INV the matrix A is this A0 inverse of A. Matrix A is this. This is the inverse of A. It should come identity matrix. Where I am doing the mistake. It should be dot actually. Matrix multiplication. Matrix multiplication will be done by dot. Just put a dot. A into INV is the identity matrix. So this is the other thing actually. A star, if I am putting a star. So maybe it is component wise multiplication of the matrix, not the proper matrix multiplication. It's conventional matrix multiplication. It is the component wise. Suppose A11 is multiplied by B11, A12 is multiplied by B12, A32 is multiplied by B32. We have to check with this operation. Just multiply two matrix, just use this. So suppose I want to take this one only. First element of this list. Suppose I want to extract first element of this list or second element of this list. Then we have to write like this. We have given a name INV. So INV. Write here 1. Extract the first element of this list. Suppose you want to extract the second element of this list, then write it here 2. Shift enter. Second element. 3, then third element. Want to extract two elements, then how to write? Should I write like this? Suppose second and third I want to extract. No, it is giving some error. We can find out, we can click here. INV cannot be followed by 2, 3. It should be a list, na? It is a list. So it should be included in this. Let me. And I am getting error. So explore yourself how to explore the two elements at a time. So these are the very important commands which you do when you do some computation or while making some code in Mathematica. You may use these commands. So we can check whether the matrix is symmetric or not, matrix is anti-symmetric or not, Hermitian or not, anti-Hermitian or not, orthogonal, unitary. All we can do. We can check for each matrix. So explore yourself and let me discuss the plot command. Plot. So how to do different things in plot. Let me discuss this. First of all, 2D plot and then come to the 3D plot. I am having 20 minutes. So actually in one lecture, it is very difficult to cover the basic and go to some higher level also, because we can solve differential equations also with the help of DSolve. We can solve the differential equation numerically also with the help of ND solve. We can solve the partial differential equation also. We can plot the solution also. So we can do much more things, but we have in one lecture it is difficult to go up to that point, because without learning the basic we cannot learn that thing, solving differential equations or partial differential equations and plotting other things. To do all those things, we have to do, first of all, we have to know all the basic things. Because suppose we want to go on the terrace, then we have to start from the first step of the stair. We cannot jump directly to the fourth step or eighth step, or directly we cannot jump to the terrace. We have to start from the first step of the stair. So we cannot skip the beginning. So let me discuss the 2D plot. So I have already explained that if you do not know how to plot a function, so just use this symbol and plot, press shift enter. You will be provided all the syntax. So just let me plot this one. Suppose plot, I want to plot. P should be capital and argument should be in square bracket, x cube minus 8x. Control 6 x cube. Let me write like this. X cube minus 8x. And I have to give the range from where to where I have to plot. So x from -5 to 5, -5 to 5. Graph. Also, we can find the minimum of multiple functions. Mathematica is helpful to find the minimum of the multiple functions. Say, suppose I want to define this function. This is user defined function. We can define a function like this. In the square bracket, x and underscore. You can define a function like this. Suppose I want to define this function as minimum of x square x cube, and let me include x also. X square x cube x raised to power 4 x raised to power 4 comma x raised to power 5 and so on. And I want to plot the minimum of this, minimum of all these together. So for this, what will you do? Just plot, plot this zx, plot zx, and suppose I want to plot from range x 0 and 2, yeah, 3, 4. Suppose we know that when x is greater than 2, then minimum will be when x is greater than 1, then minimum will be this. And when x lying between 0 and 1, then this will give the minimum x. So it's not giving the answer. Plot zx. Actually, let me clear x first. Let me clear x. Maybe where I have defined the value. Let me clear x. Clear or remove x. Remove x. Then let me do all those things. Define zx like this. It is okay. And then plot zx, x lying between this. Yeah, it is coming. Actually, the problem was coming due to the because I have defined x, or in many questions x was assigned to some values like this. X is this. X is this. So and I was using that x as a variable for giving the range x equal to 0 to 4. Then Mathematica gets confused in this case. So first of all, remove the previous variable, or clear the definition and values of the previous variable, and then do all these things. So when x is greater than 1, then this is the straight line, because x is the minimum. This x is the minimum, and this is the graph of x raised to power 5 when x lying between 0 and 1. 0 and 1. So this graph is not looking very beautiful. So we can do many more with this graph. Like we can label the axis, we can label the plot, we can make the line dash, we can make the line thicker. So all these we can do. So like plot say kya hai, control K. So we can do plot label, plot marker, plot points, plot range clipping, plot region, plot style. In plot style gives the color to the graph, and also plot style gives the thickness. Plot style gives the dashed line, and plot marker gives the marker, and plot label give a label to the plot like caption, and all other things we can do. Like we can label the axis also with the help of axis label, AXE X axis label, LABEL axis label. We can label the axes with the help of this command, frame. We can make a frame with the help of this command. In the next graph, I'm going to use all these, and we can plot label, plot LABEL label, plot legend, plot LEGEND. We can give the plot legend. Plot legend we have to load it first, and plot range, plot range. All means plot range means you can control this. You can control the range of this. So let me control the plot range. From 1 to 3. So the plot range starts from 1 to 3. We can see here plot range we can control. So let me plot a graph first of all. I'm having a very less time. Plot. Suppose I'm plotting T cos T. T into cos T. T cos T. And the value of T is from 0 to 4 pi. 4 pi. In pi, P should be capital. So just press enter. I have missed T here, na? T comma 0 to 4 pi. Just press enter. This is the graph of T cos T. Now just decorate this graph. The first one I am going to use axis label. AXESLABEL axis label. Just use this arrow. This arrow will be created by the minus sign and the greater than sign, and just press make a space. Then it will be converted into arrow. Axis label. Just I want to give T and FT. Then in the inverted comma you have to write T comma FT. TFT. we are using two things, T and FT, then you have to make a list with the help of curly braces. Okay? Shift enter. Now see, the graph is labeled. The axis is labeled T and here FT. Now let me label the plot also. So for this I have to use plot LABEL label, plot label. Just plot label, and suppose I am writing it is a simple graph. It is a simple. So just press enter. It is coming. It is a simple graph, and just suppose I want to give the grid lines. GRID grid lines. Last I want to. Suppose we want to use plot style. Plot STYLE, plot style. Plot style means with the help of this command plot style, we can give the color. Suppose I am giving the red color, then it is red. Suppose I am giving the orange color, then it will be orange. Orange. With the help of plot style, we can also give the thickness. Suppose it is red. We also give thickness. So thickness के लिए PHI. Suppose I want to dash line, DASHED dashed line. Then we are getting an error because here the option are two, more than one. So we have to include these options in the list with the help of curly braces. Don't forget these things, otherwise it will not run. So dashed line. Now we can do one more thing in the plot style. We can make the thickness more thick, the graph more thick. Thickness. Suppose I am giving 0.02. So this is. So suppose I am taking plot range all. Plot range I am taking all. Actually, you can control the range and also the domain of this plot. Suppose I am taking the plot range 0 to 5 only. Plot range 0 to 5, like this, I have to write like this 0, 5. It is going up to 10, na? Just 0, 5. So our range is 0, 5 now, only 0 and 5. I have restricted the plot range. So the negative sides are not coming in the graph. Just remove this plot range all. We can control the x-axis and we can control the y-axis also. We can control the aspect ratio also. Let me use that one. ये सारा हो गया. हाँ. So suppose one more thing I have to do. Actually, plot legend है ना? Plot legend. तो हमें एक बार यहाँ करना पड़ा plot legend. तो plot LEGENDS. We have to load this plot legend. It is okay. Now it will work. Plot legend. Plot LEGEND. Actually, in the higher version, you no need to load the plot legends. It is already loaded. Plot legend. Plot legend. Just I'm writing E cos T. E cos T. E cos T. It is coming. So we can control the position of the legend also. Position of the legend we can control. And we can control the size of the legend also. We can control the shadow of the legend also. We can minimize, maximize. If we want shadow on upper side, then we can take. We want shadow upper side, upper right side, then we can take. We can do this. If we want shadow lower left side, then we can do that also. So these will come in the plot legends options. So we can do each and everything. And suppose we want to plot more than two functions. We want to plot more than two functions on the single. Actually, just I want to show one more thing. Suppose I am plotting these two. Shivaji, are you there?
Yes, sir.
Acha, is there 10 minutes more?
No problem, sir.
Okay, just I will take hardly I will take 10 minutes because I want to complete this one.
Okay, sir. Okay, sir.
Just suppose I want to plot this plot. I want to plot two functions. So for plotting two functions, we have to make a list with the help of curly braces. And first one is t cos t, and the second one is 2 sine t minus pi by 2. Suppose 2 sine t minus pi by 2. This is the second graph. And suppose I want to give the range of t varying from 0 to 4. T varying from 0 to 4 pi, suppose. This is the two graph plotted on the same domain. We are plotting the two functions on the same domain. Domain is same, 0 to 4 pi. The domain is same. But if you want to, suppose I want to plot the first function on a different domain, and I want to the second function on a different domain, and I want both the graph on in one picture, in one figure. I want to these two. Then what to do? First of all, this is the drawback of this. The domain of all the functions are same. If you want a different domain for different function, then we cannot do here. This is the limitations of this command, plot command. And other things, if we want to control the plot style, suppose I want to plot style, plot style dashed, 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 then both the graphs will be dashed. If we want to make thicker the first graph and not the second one, then we cannot control it, because what command we will use here, it will be applicable to both the graphs, both the functions, graph of both the functions. So these are the limitations. First limitation is, suppose we want to plot the different graphs on the different domain, so we have to do something other. We have to use some other command. And suppose we want to control the plot style, suppose dashed lines. Suppose I want first curve as a regular line and the second curve as a dashed line, then we cannot do here. So these will be overcome with the help of show command. So just let me do this. Just I am giving the plot 1 equal to plot, just in the curly braces, I want to plot the first one. First one. Just it is t cos t. It is t cos t. T cos t. And suppose t is varying from 0 to 4 pi. And suppose in this I want to use plot style, plot style, plot style orange, color I want to give orange, and I want a dashed line. So this one, enter. And suppose plot 2 equal to plot the second second function is 2 sine t minus pi by 2. Let me copy here. Copy from here. Just paste here. Suppose again I want to give the variation different range 0 to 3 pi. I want to give the different range p varying from 1 to 3 pi. Sorry, 0 to वहां से input किया है 1 to 3 pi. And then plot style I need green line for that. Green line for that. And just next, I use this command so plot 1 and plot 2. Plot 1, comma, plot 2. Just plot. So this is the range, the domain of these two graphs are different. The domain for the first one is 0 to 4 pi. A domain of the first one is for 0 to 4 pi, and domain for the second function is 1 to 3 pi, and both are plotted on the same axis. The first line is dotted and second line is a continuous curve. First is orange and second one is green. So we can do like this also, and we can do many more things. We can use different legends for different graph. So I'm not having sufficient time. Suppose I do not want the output of this one t cos t, and do not want the sine t minus pi by 2 graph of this one. Simply I need this. Then just put what to put. Just give the semicolon to suppress the output. Just suppress the output. Now press shift enter. Just you are getting this one. And suppose in the second one I want to give the thickness. Suppose I want to give the 0.02. What mistake I did? Because in the plot style I am using two different options. So again I have to make list. Do not forget this. Again I have to make a list, this one, and then shift enter. Then the thickness of the second graph is 0.02. First वैसे ही है. So these things we can do. We can do a lot with graphics, 2D and 3D plots. So to plot 3D graphs, the command is plot 3D, and write the function, specify the range of first variable, also specify the range of the second variable, like this plot 3D. In the square bracket, I am writing the function x square plus y square. Suppose x square plus y square. Just I am writing, and just comma. Just give the x from -1 to 1, -1 to 1, and for the second variable y, I am giving the range -1 to 1 again. You can give some different also. -1 to 1 again. Just press shift enter. Mathematica, it is showing running. Okay. Where is the cursor? Just wait 1 second. Where is the cursor? Plot 3b, x square plus y square, x -1 to 1, y -1 to 1, and so it is showing running. I think yeah, this is the graph. 3D graph. So you can play with this. You can see. In this 3D graph also, we have a lot of options, lot of commands. You can explore in the search option, or just write the way which I have told how to explore the particular commands, or you are remembering just only 2 or 3 letters of that command, then how to explore that. And also one more thing I want to tell. Suppose by mistake, suppose Mathematica was running, it was showing running. So by mistake you created an infinite loop in any code. Then it is an infinite loop. Then it will not end by itself. Or your calculation are taking much more time and you want to stop it. Then how to do this? This is also very much important. You should know how to stop your running program, running code. So for that, just go to evaluation and here abort evaluation. Click on abort evaluation. Or you can do this by alt plus dot. Or you can do this also, quit kernel and local. So just let me explain this by an example.